All right, this video is to how to solve for S molar solubility. The previous lesson we had was to solve for KSP. So in a chapter where molar solubility, you're either going to solve for KSP typically, or you're going to solve for S, which is molarity or molar solubility. There's 4 steps, and then there's also a shortcut, but you have to pay attention to the ratios you'll see because they could ask you for either value after I show you the shortcuts. First step in all these is going to be able to write the reaction. So when you see that whatever the reaction is, the solid's going to go on the left. The ions that it's going to break apart that are slightly soluble is going to go on the right. The next thing you're going to do is fill in the mini ice table using the coefficients for the S's on the change line. You're then going to write the expression. Remember, equilibrium expression, which means the KSP expression is going to be the ions are on the right hand side, KSP is going to be on the left. We don't include solids. Last step is on the E line. You take the E line values and you're going to drop them into the expression using the given KSP in the problem to solve for S. So what does a typical problem look like? Well, if you look right here, here's a typical problem. They want to know what solubility is. That's going to be S. So as soon as you see solubility, you know they're asking us to solve for S. They give us the KSP value. So in the previous problems, we were trying to find KSP yesterday. Now we're trying to find S, or solubility. Solubility, by the way, is going to be in molarity. So first and foremost, I take CAF as a solid. It's going to break into Ca2 plus and 2F minus. The subscripts become coefficients. And then I'm going to do a mini ice table. So I'm going to do a little mini ice table, step 2. So this is going to be 0 and 0. We have no initial values. This is going to be plus S. Why? Because the coefficient there is 1. This is going to be plus 2S. And then I'm going to drop it down. I'm going to get S and 2S on my E line. So those are my E line values. Then I go to write my equilibrium expression. KSP is going to be equal to the concentration of Ca2 plus and the concentration of F minus to the second. Where does that come from? Here. I write out the expression, coefficients become exponents, I get it all set right there. That was the third step. The fourth step is you're going to drop in the values from the E line into the expression. So what's going to happen is I'm going to take the E line value for calcium and I'm going to drop it in. That's going to be S. I'm going to take the E line value for F minus. I'm going to drop it in there, which is going to give me 2S. And in the expression, it's squared. And then I'm going to take the KSP value that they gave me and plug it in there. 3.2 times 10 to the negative 11th. Now, at that point, all I have to do is algebraically solve for S. So if I take 2 and I square it, I get 4. So I get 4S squared plus another S. This side is going to simplify to 4S cubed is equal to 3.2 times 10 to the negative 11th. Then I just do a little algebra. I divide by 4, take the root 3 of the value, and S comes out to be 2.0 times 10 to the negative 4th. That is my solubility, my molar solubility of CaF2. If they want to know my ion concentration, they want to know what's the solubility of Ca2 plus in that case, I would say it's 2.0 times 10 to the negative 4th. What if they wanted to know the solubility of F minus? It's different than Ca because it's 2S on the E line. The molar solubility of that would be 4.0 times 10 to the negative 4th. So you have to pay attention to the E line if they're asking you about ion concentrations. So when you go back, pay attention to that. In this case, they just want solubility, so they're just talking about S. So you solve it that way. They could, in the end, ask you about the concentration of Ca, which is the same, or the concentration of F minus. Here's another problem. Same exact thing. First thing you're going to do is write the reaction. So I'm going to write the reaction. I'm going to say MgF2 as a solid is going to break into Mg2 plus 2F minus. Bam. Next thing I do a mini ice table. ICE. No initial values, so it's 0 and 0. Plus S plus 2S. If I drop it down, I end up with S and 2S. Then I write my expression. So when I go to write my expression, it's going to be it's going to be KSP is equal to the concentration of Mg2 plus to the first, concentration of F minus to the second. Then I drop my E-line values. I'm already given my KSP, so I know this is 6.4 times 10 to the negative 9th is equal to, this is going to be S. This is going to be 2S inside here. That has to be squared. When I simplify the whole thing, I end up with the exact same kind of problem I had last time. 4S cubed is equal to 6.4 times 10 to the negative 9th. So if you do the math from that point on, you basically divide by 4, take the cube root of it, you get 1.2 times 10 to the negative 3rd for S. That's also my concentration. If they're asking me, well, what's the solubility of magnesium? I would say it would be 1.2 times 10 to the negative 3rd. If they ask me my solubility of F minus, which sometimes they ask, that's going to be 2.4 times 10 to the negative 3rd. Because it's double because of the 2s. You go back to the E-line if they ask you about molarity of the ions. It's always the E-line. You always want to do it in that same order. Now, if you notice, if you go through this, every time we had 3 ions in both of those examples, it was a 1-to-2 ratio. Your KSP is going to be equal to 4s cubed. Here are the 4 most common calculations, the only ones they include in the AP exam. So you could almost sit and memorize them. If it's a 1-to-1 ratio with the ions, you're going to always have KSP is equal to S squared. It's kind of a shortcut. Do you have to do the ICE table? If it was the AP exam, yes. But if you realize it's 2 ions, you could just say S2, S squared is equal to KSP. We already did this example twice, actually. There's that one. What if it's a 1-to-3 ratio of ions? So something like, let's say you were breaking up aluminum chloride, and it was a solid. And so it's going to be a 1-to-3 ratio, 1 aluminum for every 3 chlorides. Your KSP will be equal to 27S to the 4th. Finally, if you had something that was a 2-to-3 ratio, very rare, but if you did have a 2-to-3 ratio, KSP is equal to 108 S to the 5th. I would jot all those down on your guided notes. Those are quick little ways to solve. So when it asks you to solve for solubility, it's asking you to find S. You could almost use a shortcut, except if it was the AP exam, you would have to actually sit and do an ICE table. All right, go ahead and complete the problems for homework 16-2. You should be good to go.